Welcome to the second in a three-part series on EPA's Best Management Accounting and Tracking Tool, also known as BATT. This video 2 of BATT provides the information on data input, mechanics, and reporting features of the tool. Another video 1 of BATT provides more details on the background and basics of the tool. Video 3 provides real-world examples, tool application, and troubleshooting tips. My name is Khalid Alvi, and I am a water resources engineer with extensive experience in the development of linked watershed and stormwater BMP modeling systems. I lead teams of computer programmers and watershed modelers to produce applications and software for federal, state, and municipal agencies. I led the development of spreadsheet-based stormwater management optimization tool known as OptiTool tool and BMP accounting and tracking tool known as BATT for US EPA Region 1 to support the small MS4 permittees in identifying the cost-effective mix of stormwater controls that meet the permit requirements. I am a registered professional engineer in the state of Virginia. This video will cover some key questions commonly asked on the topics of data entry, mechanics of the tool, and report generation. For example, what baseline data are included by default? What types of land use, land cover can I select for BMP drainage areas? What project types can I enter? What specific data is needed to track projects and account for BMP credits? How do I launch the BATT? How do I navigate the BATT? How do I edit an existing project? How do I manually enter a project? How is BMP credit estimated? How do I import or export projects? What is included in the summary report and how do I export the project report? And what additional resources exist? So all these questions will be addressed in this video. The first topic covers the input data, including what data already exists in the tool by default and what additional information is needed to use the BATT. Video 1 talked about how the tool can be used in other regions, but baseline data is for New England. BATT was developed using the region-specific data. Logan Airport weather station was used for continuous historical rainfall data from 1992 to 2019. EPA swim model for buildup and washout processes was calibrated to the regional observed stormwater data to generate long-term annual average pollutant export rates. An EPA sustain model for BMP simulation was calibrated to regional observed BMP performance data collected by University of New Hampshire to generate long-term cumulative load reduction performance curves. Land use change can lead to changes in pollution in the environment. This tool can track those positive or negative changes because of different pollutant loadings generated from these type of land uses. BATT provides the options to pick one or multiple land use land cover for BMP drainage areas. There are 8 options for impervious cover by land use type representing the pollutant sources that include commercial industrial, high density residential, medium density residential, low density residential, highway transportation, open land, forest, and agriculture. There are also 7 options for pervious cover by soil types that are hydrologic soil groups representing the runoff potential due to varying soil infiltration rates. Hydrologic soil group A represents the highest infiltration rate with the lowest runoff potential, whereas hydrologic soil group D represents the lowest infiltration rate with the highest runoff potential. BMP types affect how much pollution enters water bodies. Each BMP performs differently due to different treatment mechanisms such as infiltration or filtration. BATT provides the option to enter structural and non-structural project types. The structural projects provide the storage capacity to capture the runoff and reduce the pollutant loads from the connected drainage areas. The structural BMPs in BATT include biofiltration, enhanced biofiltration, extended dry detention pond, grass-field, gravel wetland, infiltration basin, infiltration trench, porous pavement, sand filter, and wet pond. The non-structural programs minimize the pollutant loads at the sources. The non-structural BMPs in BATT include catch basin cleaning, enhanced street sweeping program, disconnect impervious area with or without storage, fertilizer bans, and leaf litter collection program. BATT requires the following information to collect ahead of time when you are getting ready to enter a project. Permit information includes the name of town, permit type, permit number, and if any load reduction target. BMP project information includes the BMP types, design storage volume, major watershed, major receiving water body, and start complete date of the project. BMP land use information includes the total drainage area. And the property information includes the name of owner, address, parcel ID, and contact information. The second topic covers the mechanics and report generation in BATT. BATT is an Excel spreadsheet, and when you open the BATT, it will first require enabling macros that will just apply to this workbook. Please follow instruction in the BATT user's guide on how to set up the security settings. 6 key worksheets are exposed to the user for updating the default data with EPA approval first. BATT user's guide provides details on each worksheet. A Launchpad command button opens the user-friendly interfaces for data entry, importing and exporting the project information, and generating a project summary report in Microsoft Word format. This is BATT's main user interface window that allows users to navigate the tool. You can add a new project or you can edit an existing project. You can import or export project in CSV format text file, or you can view and export project summary report. You can add data in 2 ways, manually input or import projects. If you are importing projects, make sure that each project ID is unique, and it could be a descriptive title. Also make sure you don't import the same input file twice or more than once to avoid the duplicate records. To edit an existing project, first you select your state from this pull-down list, then select your municipality, your major watershed, and the permit type. Based on the above selection, a list of existing projects will be populated for your structural, non-structural, or land use conversion projects. Next, you select a project from the list of existing projects that you want to edit and click on the Edit button. If you want to add a new project, you can click on Add Structural Projects, or Add Non-Structural Project, or Add Land Use Conversion Project. This interface is for manually entering a structural BMP project. The information is organized in 3 tabs: BMP Land Use Information, BMP Information, and Property Information. You can navigate between these tabs by clicking on any tab or clicking on the next button. So first thing, you enter a unique project ID, which can be a descriptive title. Then you select your project type, whether it's a new development or retrofit, BMP. If it's a new development, then you have to enter a land use change project information separately. Then you enter the BMP drainage area information by selecting the land use type from the pull-down list and enter the land use area. If you select land use type as a pervious land, and then you also need to select the hydrologic soil group A, B, C, or D, and then click on the Add button to move the data inputs to the right-hand box of the BMP drainage area. Next, click on the BMP Information tab or the Next button. Under BMP Information tab, you select your BMP type from the pull-down list. If you know your BMP site-specific infiltration rate, enter that information here, or use the nearest infiltration rate provided in the pull-down list. Enter your BMP design storage volume. Check the boxes to ensure the BMPs were built and maintained to design specification. Check the box for O&M plan. Enter the date of BMP completion, date of last inspection. BMP credits are estimated for an active BMP that is well maintained and built to design specification. If these boxes are not checked, then no credits will be provided for that project. And then click Next. The Property Information tab is used for project tracking purposes and is not required for calculating BMP credits. Under this tab, you can enter the subcatchment ID, for example, outfall catchment where your project is located. If you have any local permit ID, owner's name, parcel ID, contact phone number, parcel size, property zoning, parcel total impervious cover, and property address. Click on Save to save your project and close the user interface. This interface is manually entering a non-structural BMP project. Just like structural BMP project, the information is organized in 3 tabs. And under Land Use Information tab, you enter your unique project ID, which can be a descriptive title. Enter your BMP drainage area information by selecting land use type from the pull-down list. Enter the land use area, click on Add button to move the data input to the right-hand box of the BMP drainage area, and then click Next, or you can click on the BMP Information tab. Under BMP Information, select your non-structural BMP type, for example, Enhanced Sweeping Program. From this pull-down list, enter start date of BMP implementation, select a sweeper technology from the pull-down list, sweeper frequency, and enter number of months sweeping program was implemented in a year. Check the box for active BMP because BMP credits are estimated for active BMP only, and then click Next. Owner information is for project tracking purposes and is not required for calculating the BMP credit. The information under this tab is very similar to structural BMP projects, so you can enter the information and click on Save button to save your project information and then close the user interface. This interface is for manually entering a land conversion project. If your project is a new development project, then you must enter this information. Just like structural and non-structural projects, the information is organized in 3 tabs. Under the first tab, which is Land Use Condition Before, enter a unique project ID, and then enter the land use information for your existing condition. For example, if you are converting a natural forested land into a commercial lot, you would select a forest pervious land use type from the pull-down list. P stands for pervious. Enter the area, how much forested land will be converted into commercial, and then click on Add button to move the data input to the right-hand box of the BMP drainage area. Then click Next or click on the Land Use Condition After tab. Under Land Use Condition After tab, you enter the project completion date and the developed land use information. For example, if you are converting natural forested land into a commercial lot, you will be disturbing the soil and creating commercial impervious and pervious footprint. So in that case, you should be entering the information for both pervious and impervious commercial land use. To do so, you select the commercial land use type from the pull-down list. For example, commercial pervious, P stands for pervious land, and enter the area, how much area is pervious, and then select the underlying hydrologic soil group and click on the Add button to move that information to the right-hand box. Repeat the same step by selecting commercial impervious land use type from the pull-down list, enter the area, how much area is paved, and then again click on the Add button to move that information to the right-hand box. Next, you click on the Next button or you click on the Property Information tab. The Property Information tab is used for project tracking purposes and is not required for calculating BMP credit. The information on this tab is similar to structural or non-structural projects. So you enter the information and then click the Save button to save your project and then close the user interface. BMP credit is estimated by multiplying the land use loading rate, BMP drainage area, and BMP performance. The land use loading rates were developed using the EPA SWIM model to simulate 28 years of continuous hourly rainfall runoff response. The long-term annual average loading rates for total phosphorus, total nitrogen, and total suspended solids represent a wide range of storm sizes from small to large and different antecedent moisture conditions. The BMP performance was developed using the EPA SUSTAIN model by simulating BMP processes such as infiltration, evapotranspiration, and pollutant removal at hourly time step. The continuous hourly output from the SWIM model was used as a boundary condition for BMP simulation. The cumulative annual load reductions for TP, TN, and TSS represents the BMP performance under a wide range of storm sizes from small to large for 28 years of rainfall data. The BMP performance curve represents efficiency for a range of BMP sizes in terms of design storage volume. BATT estimates the BMP performance from the curve based on the design storage volume of your BMP project. Note that the permit gives credit for pervious cover as well, but the emphasis is on impervious cover. Import and export features give BATT greater flexibility to interact with other tracking and accounting programs. BATT uses a comma-separated value CSV text format with a fixed number of and order of columns for each project type. If you are not familiar with the CSV data format, then the best practice is to enter a project manually first, export it, and then follow the same format to create a compatible data CSV file for your project types. Follow the BATT user's guide for detailed information on the data requirements for the CSV file. From the user interface, first select your state and your municipality from the pull-down list. If you are importing your projects, then browse to CSV file locations using the Browse button on the interface and click the Import button. If you are exporting your projects, then specify the file name and location using the Browse button on the interface and click the Export button. Note that import your project files once only to avoid creating duplicate projects. Once you are done, click on the Close button. The summary report shows the progress and identifies the gap in achieving the load reduction target. From the user interface, first select your state, municipality, major watershed, and the permit type from the pull-down list. BATT automatically filters the existing saved projects in the tool and shows them by project type. BATT estimates the pollutant load reduction credits for total nitrogen, total phosphorus, and total suspended solid by project types, and shows the total load reduction against the required load reduction target value for the selected watershed in the selected municipality. To export the summary result in a Microsoft Word document, specify the file name and location using the Browse button on the interface and click the Export button. Once you are done, close the interface. Some of the frequently asked questions are: what versions of Excel are compatible? Is BMP terminology consistent with Massachusetts MS4 permit? How do I gather, calculate land cover, land use, catchment area information? How do I select, enter site-specific infiltration rates for a structural BMP? How do I calculate the catch basin drainage area by outfall catchment? How do I estimate the frequency of street sweeping actions? To see all frequently asked questions and answers, please visit the FAQ page on the Southeast New England Program website. Appendix C in the BATT User's Guide document also provides responses to those frequently asked questions. Thank you for listening to the second video of the BATT. For a big picture background of the tool, please see video 1 on the history and application of the BATT. And for real-world application, please see video 3.